If two real numbers or two algebraic expressions are replaced with equality with the symbols less than, greater than, less than or equal to, and greater than or equal to, they form an inequality. The inequality reverses its direction if we multiply or divide both the side of the inequality by the same negative real number. This region is common for both the linear equation. So therefore, the number must be greater than or equal to 6. So therefore, the solution set is 6, infinity. Hello everyone, a warm welcome to one and all. This is Shruti ma'am, lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we are going to take up the new chapter, chapter number 7, Linear Inequalities. Now, previously, we have learnt about the algebraic equations. We have also solved in the theory of equation about the linear, quadratic as well as cubic equation. Now, we are studying about the inequalities. So, what do you mean by inequalities? Before that, let us see the weightage of this chapter. Now, under chapter 7, linear inequalities here. So, you will be having multiple choice question for 1 mark and short answer 2 mark for 1 question, long answer 3 mark 1 question. So, overall 3 questions for 6 marks. Let us see what do you mean by inequality. So, if two real numbers or two algebraic expressions are replaced with equality with the symbols less than, greater than, less than or equal to, and greater than or equal to, they form an inequality. For example, 3 less than 7. This is a numerical inequality. X greater than y. Two algebraic expressions here which forms a equality. For example, 3x minus 7 less than or equal to 0. So, this also form an inequality. Now, 2x plus 3 greater than or equal to x minus 1. This also form an inequality. So, everywhere here you can clearly see instead of equality we have less than or greater than symbol along with the equality, which are called as inequalities. Now we talk about the linear inequality. So linear inequality, we are already familiar with the linear equation. So general form of a linear equation in one variable is ax plus b. This is a linear equation. If we want with the two variables, then ax plus by is equal to c. So this is an example of linear equation with the two variables x and y. Now here, if in this equation, if this equality is replaced with less than, greater than, less than or equal to, and greater than or equal to, where a, b, c are real number, and we clearly know that when we want to say linear function, then your a cannot be equal to 0 because the power of the variable must be 1, where a constant cannot become 0 or the coefficient of the variable cannot become 0. So therefore, considering a not equal to 0, so an equation of this form is called as linear inequalities. In this session, we are going to find the solutions for linear inequalities. Now, we will see the rules for solving the linear inequation. Now, suppose an equation is given. Rule number 1 says the inequalities does not change if the same number is added and are subtracted to the side of the both side of the inequality. Now, consider an equation. We have 2x plus 3. So, greater than 1. So, in case of equation, what we will do? We will do the process called shifting. Shifting from left hand side to right hand side and right hand side to left hand side. So, here we will not do the shifting process. Instead, we will add the common number or we will subtract the common number in the both side to solve the inequality. So, what I will do here? I will subtract 3 on both sides. Then here I will get 2x greater than. So, 1 minus 3 becomes minus 2. Next thing is, it's a multiplication or division rule. What does it say? The inequality does not change if we multiply or divide both the side of the inequality by the same positive real number. So we need to divide to get the solution for x such that the inequality should not change. Now, if we divide both sides by 2, we will get x greater than minus 1. So here, x greater than minus 1 is the solution for this equation. That means all the numbers which are greater than minus 1 will act as a solution for the given inequation. So Now suppose rule number 3 says the inequality reverses its direction if we multiply or divide both the side of the inequality by the same negative real number. Consider an example. Minus 3x less than or equal to 3. Since I need the value of x here, I am dividing both left hand side as well as right hand side by minus 3. When I divide by minus 3, here this is x and here it is minus 1. Whereas the inequality changes to greater than or equal to. So when you are dividing or by multiplying with the negative number, you need to change the sign of the inequality. So these are the rules we should follow when we are solving the inequations. Solve the following inequalities. First one, 3x minus 4 greater than 7 minus 2x. So here I will add 2x on both sides so that I can remove minus 2x here. So if I add 2x on both sides, 3x plus 2x is 5x, minus 4 is as it is, greater than 7. What I have done here, I have added plus 2x on both sides. Next here, I don't need 4. Here I have minus 4. So to remove minus 4, I will add plus 4 on both sides. Then I will get 5x greater than 7 plus 4, which is 11. So here I have added plus 4 on both sides. Now I will divide by 5 on both sides. So I get x greater than 11 by 5. So now here clearly the solution belongs to the set of real numbers. So all the numbers greater than 11 by 5 will act as a solution for the given set of linear inequation. So therefore, x belongs to the interval which contains 11 by 5 until infinity. So when you are having a less than or greater than, that is strictly less than or strictly greater than, we always use the open interval to represent the solution set. The solution set of real number is always written in the interval form. So from between 11 by 5 to infinity, all the numbers acts as a solution for the given inequation. Next, 3 into x minus 1 less than or equal to 2 into x plus 3. So first let us solve the equation here. 3x minus 3 less than or equal to 2x plus 6. Now, I will remove 2x on both sides. To remove that, subtract 2x. 3x minus 2x, x. 2x minus 2x cancels. I don't want minus 3 here, so add a 3. When you add 3, it cancels. And here it becomes 9. So, x is less than or equal to 9. That means x belongs to the set less than or equal to 9 means it can also include 9 until all the negative real number. So minus infinity indicates the least real number. So here, so we always use the open interval. So the solution set for the given equation is minus infinity comma 9. So less than 9 means all the numbers less than or equal to 9 will form a solution for the given inequation. Next. Solve linear inequalities in one variable and represents the solution on the number line. So whatever we have written the solution, we will express it in the number line. So 3x minus 9 greater than 0, which implies 3x is greater than 9, x is greater than 3. So the solution says x is greater than 3. That means x belongs to the interval. So greater than 3 means the number after 3 until the highest number, which is infinity. So when I write open interval, it means after 3, any number after 3 will act as a solution here. Now I'll write a number line here containing integers 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, etc. Now clearly the solution says x is greater than 3. That means I cannot include 3. So I will draw open circle above 3 and I'll draw a direction such that greater than 3 means obviously it is on the right side of the number line. So therefore, I'll write an arrow mark here. So any number which is greater than 3 on the number line represents the solution for the given inequation. Next, 3 into 1 minus x less than 2 into x plus 4. So here when you solve this, 3 minus 3x less than 2x plus 8. Now let's solve this. I don't need 3 here, so I'll subtract 3. Minus 3x less than 2x plus 5. 8 minus 3 is 5. Now, to remove 2x, I'll subtract 2x on both sides. Then minus 3x minus 2x is minus 5x less than 5. Now, I'll divide by minus 5. Remember, we have minus 5 and we are dividing by the negative integer. So, when you are dividing by a negative number, you need to change the inequality sign. So, less than becomes greater than, and here x greater than minus 1 is the solution. So, that means all the numbers after minus 1 will act as a solution set. So, therefore, minus 1 comma infinity is the solution. Now, to represent it on the number line, so clearly this is the number line. So, here we'll draw an open circle because we are not including minus 1. All the numbers after minus 1, which means it is on the right side of minus 1. So, this acts as a solution for the given inequation. Next, solve the following inequalities. We'll just find the solution set for the given inequation. So, here we have 2 and we have 4. Let us solve the right hand side. So, 3x minus 4 divided by 2 greater than or equal to x plus 4 minus 4 divided by 4. 3x minus 4 divided by 2 greater than or equal to x, 4 and 4 get cancels, divided by 4. Let's take the LCM of 2 and 4 here. So, when we take the LCM of 2 and 4, the LCM is 4. We'll multiply 4 on both sides. Then here we are left with 2 into 3x minus 4 greater than or equal to x. So, next we have 6x minus 8 greater than or equal to x. So, subtract x, then we'll get 5x minus 8 greater than or equal to 0. Add 8, then we'll get 5x greater than or equal to 8. So, here we get x greater than or equal to 8 by 5. So, therefore, the solution set is x belongs to, since it is equal to 8 by 5, all the numbers after 8 by 5 will act as a solution. So, we will write a big bracket or a closed bracket to represent the solution set since it includes 8 by 5. Next, 37 minus 3x plus y greater than 9 minus 8 into x minus 3. X belongs to integers. So, 37 minus 3x minus 5 greater than 9 minus 8x plus 24. Now, 37 minus 5 is 32 minus 3x greater than 9 plus 24 is 33 minus 8x. Add 8x on both sides, then I'll get 5x plus 32 greater than 33. Subtract 32 on both sides, 5x greater than 1, x greater than 1 by 5. So, when I say 1 by 5, it is 0.2. So, that means I need to take the integers which are greater than 0.2. So, what is the next integer which is greater than 0.2? It is 1. So, all the numbers greater than 1 by 5, that means all the integers greater than 1 by 5 is the solution. So, after 1, it is 2, 3, 4, etc. until infinity. So, therefore, the solution set for this is the positive integers. Next one, x by 14 less than 5x minus 2 by 3 minus 7x minus 3 by 5. So, let us solve this using the LCM of 3 and 5. We'll keep as it is x by 14. The LCM of 3 and 5 is 15. So, here it is 5 into 5x minus 2 minus 3 into 7x minus 3 whole divided by 15. X by 14 less than 25x minus 10 minus 21x plus 9 whole divided by 15. X by 14 less than 25x minus 21x is 4x, minus 10 plus 9 is minus 1 divided by 15. So, now 14 and 15 we have. So, this can also be written as 15x less than 56x minus 14. Now, subtracting 56x on both sides, we will get minus 41x less than minus 14. Now let's divide by minus 41 on both sides. So here the inequality changes to 14 by 41. So therefore, since x belongs to the real number, the solution set is all the numbers greater than 14 by 41. That means until infinity. So this is the solution set. Next. Solve the following system of linear inequalities in one variable if x belongs to R. So here the condition is x belongs to the set of real numbers and we have two linear inequalities here. So based on the two condition, we need to find the common solution for both the inequalities. So now let us solve this. We have 1 minus 7x by 2 greater than 3. When we multiply 2, we'll get 1 minus 7x greater than 6. Now when we subtract 1 on both sides, we will get minus 7x greater than 5. Next, we'll divide by minus 7. Then x is less than minus 5 by 7. So, here the solution set is any number less than minus 5 by 7. Now, let's solve this inequality. So, we have 3x minus 8 less than minus 55. Now, 3x minus 8. To remove minus 8, I'll add plus 8 on both sides. So then this is less than minus 47. So x is less than minus 47 divided by 3. So if you consider this as equation 1 and this as equation 2. So here x is less than minus 5 by 7 and here x is less than minus 47 by 3. So clearly, minus 5 by 7 is greater than minus 47 by 3. So therefore, the common solution will be minus 47 by 3. So therefore, x belongs to the solution minus infinity to minus 47 by 3. Next one, 2x minus 5 greater than or equal to 7. So then 2x is greater than or equal to 12. X is greater than or equal to 6. So let's take this as equation 1. And here, so multiplying by 1 plus 2x, we'll get 2x minus 1 less than 3 plus 6x. So adding 1 on both sides, we get 2x less than 4 plus 6x. Subtracting 6x minus 4x less than 4. Now dividing by minus 4, x is greater than minus 1. So this is equation 2. If I represent this on the number line, so it is a number which is greater than 6. And this is a number greater than minus 1. So it is behind somewhere here. So greater than minus 1. So obviously, this region is common for both the linear equation. So therefore, the number must be greater than or equal to 6. So therefore, the solution set is 6, infinity. Next, 3x minus 7 less than 5 plus x and 11 minus 5x is less than or equal to 1. So here, to remove minus 7, I'll add 7 on both sides. Then I'll get 3x less than 12 plus x. Subtract x on both sides. 2x less than 12. Divide by 2, x less than 6. So this is equation 1. Now here, 11 minus 5x less than or equal to 1. To remove 11, I'll minus 11 on both sides. So minus 5x less than or equal to minus 10. I'll divide by minus 5. X is greater than or equal to 2. Now here, this is the number line where x is less than 6. So this is the region. This side, all the numbers x less than 6 will act as a solution. Now here, this is the solution. Somewhere here if it is 2, so it includes 2 and it is greater than 2. All the numbers which is greater than 2. Obviously, my solution set lies from 2 to 6. Which includes 2 but does not include 6. So therefore, the solution set here is x belongs to 2, 6. So that means all the numbers which are greater than or equal to 2 and less than 6 will act as a solution for both the inequations. So in today's session, we have discussed to find the solution of linear inequalities. I'll meet you in the next session. Until then, keep watching, keep learning and keep exploring. Thank you.